I expect you to have gone through the practical 1 to 4 yourself, to have checked it before you actually come to these other ones, as I will be only be showing you how you can run this other one from practical 5 to the end using the online method, which the Google Colab, which I've already forwarded that to you in your practical 4. Can you see this is under your practical 4? You can see the Google Colab. So once you have your Gmail, next is to just to sign into your Google Colab and then continue your so what you need to do is you'll have created a notebook, and here just type your the name of the practical, but I will be using this same environment for is for everybody here. So EEC, is it 323 now? Is it 323 Python? So for Python for electrical, so I'll be using it to run all the practicals and see how we get the output. Don't forget, when you are writing your practical report, you are not expected to write this brief introduction. The brief introduction is for yourself, and the observation I put there and the result, they are not what you are expected to write there. They are just a sample of what needs to be there. So this hello from Google Cloud, you need to put hello from your own word. Okay, let me start from practical 4. I'm running through the practical 4 now. So the procedure: initiate session, which I've launched. Launch your web browser. I've launched my web browser. Generate document workspace. I've generated my document workspace, clicking the new notebook. Then configure workspace. I've configured the workspace. Then I will now be copying this. From this, I've changed this one to, you say change it to Colab setup test. I'm not using Colab setup test. I'm using EEC323 Python. You can put your own name there so that you recognize it, or use this EEC232 Python. So I'm going to copy this. So just to test the environment, then you come to this is run, and then you paste your code there. So once you paste your code there, you say print. If you look at this, it's going to import the system. Print this. Print is telling us what it's going to display. Print hello from Google. I won't be saying hello from Google. We say print hello from Federal Polytechnic Ileology. That is what I want it to display there. And I am, then you put your name. I am Adeniji Olumuyiwa Israel. So that is what you should put there. So let's run this thing and let's see what's going to happen. So if you click this, it will show 1, 2, 3 dots. If it is running well, where is going to display your output. Your output is going to be displayed under this code. So we are waiting for the output to display. Can I say this is the output? Hello from Adeniji Olumuyiwa Israel. I am from hello from Federal Polytechnic Ileology. I am Adeniji Olumuyiwa Israel. Then it puts the date. I put the main March 4, 2026, 9, and then this system version. Put the version of the system version. You understand? The system version. That's what is pulling out now. So this is what you are expected to write as your output. You are not expected to write this as your own output. So what I use here, so I will just copy my own code here, since my code is different from what is there. So I'll put it here, then you change that, put your name. Okay, just change this one alone. Hello. So I'm only changing this. I'm not going to change it because this one I'm asking it to display the version. So I'm going to correct that now. I'm going to correct that. I want to rerun this. V. So run. So just put the name of your school here. Cloud Architecture Core Python version. Then that is the version and when the version was released. The version of the Python that is running on this Google Colab. So this is the name. So that is this is your output. Don't forget, up here is your input, down here is your output. So can you see? Once you see this 3 dot, that's where your output is. So you come here, then that is what you are going to copy. Let me put my own output here. So that is my own output. Run it, you can run it, you don't need to install anything. So run it on your system and get your output and put it there. Then write your observation and your conclusion. I've told you that what I put here is just for your practical. It's not necessary you copy what is here. You write your observation. The second one is setting up Python environment and developing an Ohm's law. So let's go there. You write what you need to write. Title, aim, objectives, your equipment. You don't write this brief introduction, don't forget, it's just for you. Then go to your procedure, local environment setup. We are not using local environment, you are using the online environment. But local environment is there if you want to use your system based on the practical 3 where you install your is it practical 3 or practical 2? Yeah, practical 3 where you install your where you download and install your Python on your local environment. So yeah, we are using the online, and this is Ohm's law calculator, but I'm not changing this. I'm going to use this same interface for everything just to save my time. So the Python code, so what I will do is to copy the Python code here. And just copy everything like that. Then here, this is where we paste it, code. Yeah, not test. If you put test there, it's just a plain test. That means it will run as a code. But if you click code, then that means it will run as a code. So can you see? But anywhere you see this hash, the hash is to tell you that this line is a comment. It's not going to run. Or this one now, this is going to print out. So by the time you now run it, so let's run it. If you click this thing, this go, it will run. Can you see? It is a Ohm's law calculator. You understand? We are talking about voltage equals to I over R. You understand? Now, select the value you want to calculate. Now, here, now, what do you want to calculate? It depends on what you are giving. It depends on the variables that you are giving. So what do you want to calculate here now? Let's say we want to calculate voltage. Voltage is equal to I over. We don't need to do the formula. We specify it. We want to calculate 1, which is the voltage. Enter now. Enter current. So we need to enter the current that we are given. That is according to the formula we given. So 3 amps. Then you enter the resistance. Let's say 10 amps. So to now calculate the voltage for us. So let's go down here, guys. Result, calculated voltage is 30 volt. You understand? So calculated voltage is. So you are expected to have different. You can't have the same thing here. So that is why I said that what I put here, execution, it will run. So what I put here is just for your practical. So you don't expect to have all these things because the result, can you see the result here is 25 volt because what they supply is 2.5 and ohms is 10. But here what I supply is 3 and my ohm is 10. I have a different result. So everybody is expected to have a different result because you are expected to run this thing for yourself. What you are doing installation, explicitly adding Python to the system part environment. I don't think this one is necessary because we don't use on ground. We don't use that one. We use this one. Google Colab require no local installation or system overhead running. Of course, that is it. User inputs from the function default to a test. Can you see? That means it asks you to input something. That is where it shows this one. Logical error handling, e.g. checking if current or resistance equals 0. Prevent the program from crashing due to runtime. Here you understand. So the objective of setting up local and cloud-based Python platform were achieved successfully. Python was correctly configured locally via system disk and access online using Google Colab. Furthermore, the Ohm's law script demonstrate how basic programming logic typecasting and condition works here and there. So coming to the second one, circuit analysis. I've just been copying the code. You know what to write. You are not expected to write this brief introduction. Don't forget. Then procedure. These are the procedure. This is the code we are running. This is the library that is going to work for this code. NumPy. So I'm going to copy this. I'm going to copy that so that I'll be able to see the code. Paste. Then run. So don't forget these are the 3 dots. Summation analysis result. This is mesh current analysis. This is mesh current 2. This is total source power, and this is a total distributed power. It's going to be exactly what is being displayed here because the value here has already been the supply. The value here has already been the supply. Say circuit mesh current simulation. We are only doing the simulation. So if you see this hash, don't forget, it's a comment. It's not part of the code that is running. So constructing the resistance matrix A based on Cashio's voltage law coefficient, KVL. I'm sure you remember the Cashio voltage law and the Cashio's current law. So that is what they are R1 plus R3, comma, minus R3. Can you understand? So here and there, then this is, we run it, they already supply the values, and solving the linear matrix equation, this is what is going to solve. Then this is going to print. Verification of power is going to verify the power. Then it's just a simulation, just to test, to be sure how this thing can run. So now we are having our output. So I'm going to the next one. Don't forget to write your observation and conclusion. You are not expected to write this observation and conclusion directly like this. Don't forget, I'm telling you that. So let's go to practical 7. It seems that I'm fast. I expect you to go through this thing in your own pace. You understand? Just like we did in the theory. You understand? So let's run this one and see what is going to happen. What is this one now? Signal processing. Is it signal processing? Yeah, signal processing. The time domain, generation, noise correlation, and some other things. So let's run it and see what will happen. So now it's showing error. There is an error message here. So the next thing is processing array. Explain the error. Once you click the explain the error, it will edit here. Can you see? It's going to check it here, then tell you signal processing in time domain. It has actually displayed the time, the signal representation in time domain, and we are waiting for the time to display. So, but let's check the error that it's talking about. So the error occurs because the keyword argument is no longer valid. That is use line collection, plot this. So let's accept and run the correction needed. So once they run the correction, I will copy the correction and paste it there. Aha, good. So now that means you have to recopy all these things. Okay, let me see. Let me see if I can copy from it. Copy cell, yeah. I've copied the cell. That is because it has, that means a kind of a modification has been done on the cell. So you have to copy it, then paste it here to replace this. Paste. So that's pasted it here. Say the program output a visual graph panel with 2 subplots. Like the first one is time domain and the second is frequency domain. So let me see. This first one is what? Signal representation in time domain. Signal representation in frequency domain. So this is the output. You need to copy this output so that, because copy the image, because you are going to be printing it. You are going to be printing it. You have to print it and attach it. Oh, sorry. Paste special PNG. Okay. So I think it should paste. So you have to copy it to your paper and print it out. You have to print out what you get and attach it. Please, it is very necessary that you attach it. This is our result here. So you need to attach it. Very, very necessary and very, very important. So this is the output here. Please take note of that. For the time domain and from the frequency domain. So let's check the practical 8 here. So what are we dealing with? Control system engineering, transient step response analysis, and performance evaluation of a second order control system. So you can use this to solve your problems. Don't worry, I will still show you that. So let's copy this. It's still a simulation, so if there is any error, we are going to know and do the correction also. Let's run this. So now it is running. I've told you that it's supposed to come here, and there is another error. Then explain the error. When you click explain error, it will come to Gemini here. Then check the error and modify the error. So that is why one of the reasons I prefer to use online Python, because if there is any error, then you'll be able to debug it easily. You will see the explanation where the debug or where the error occur. You understand? Say the error mode do not found error means that the control library, which is essential for this code, is not installed. So so it's going to install the library now. That means, can you see this control library pip install Python control is supposed to be there. So I think we actually we skip it. I think it's supposed to be. It will have mentioned it. It was supposed to have mentioned it earlier. Supposed to have mentioned it earlier. Oh, can you see? Can you see? Look at the example. Python control system library and plotting tool. Pip install control matplotlib. Can you see that I'm not supposed to have mentioned? So we're supposed to have installed this one before we actually run this program. So that was what it detected. Then it's actually trying to is installing this. So once the installation is complete, then it will tell us to accept and run. So we accept and run. It's installing another upgrade. So let's see what is happening. Let's go to the output and see. Okay, there's another error here. Let's see what happens. The error means the control library, which is essential for this code, is not installed. Okay. Okay, what will happen is let's pip install this. Let's install this thing. Let's install it separately. Let's come here. V install. Don't forget what we did. Could not find the version that satisfies the requirement Python control from version. No matching this way. Found for Python control. Wow. What happens? Okay, let me see. I think what is specified here is different. Let's see this one. Pip install. Let's copy that one. Pip install this. Okay. Maybe the name has a problem. So let's try it again. Oh, can you see? Pip install control matplotlib. So that is the original name. So let's now paste our code after the installation. Okay, we satisfied that. Let's copy our code now. Okay, don't worry about that. Let's copy our code here. Then run. So that's what will happen. Okay, running. Good. Can you see? So let's see. The script generates a transient step response plots that reveal the following system metrics. So it shows you all these metrics. So the result curve rises quickly. So we are going to copy that. I'm going to copy that. Copy this. Then you need to print it. You need to print it. Okay, go to paste special png. Okay, good. So you need to print this and attach also. This needed to be printed and attached. So the result curve rises quickly, overshoots the target value of 1 than 1.0 and passes through a series of gradually shrinking oscillation before settling at a steady state. That's the first response, the transient step response, then before it now get stable. So this is the target command input the under damp zeta point. So this is selecting a damping ratio of this zeta equals to 0.4 creates an under damp 0.4 what? That 2.4. I want to see the sign. That's okay. 0.4 zeta. What is the value? I will look for it. I have to look for it. Okay. Select the damping ratio of this equals to 0.4. Create. Okay. There is no value there, so let's remove it. Zeta has no value. Create an underdamped system. It reaches the target value quickly, but exhibit a 25.38% peak overshoot. Then increasing the zeta towards 1.0 damps output, and that is the observation, and on and on like that. So I hope you understand. So this other practical that I put here, I'm sure you'll be wondering, what do we need to do? What you need to do is one of them is going to be your practical This is practical 8. Yes, one of them will be your practical 9. So you just do it yourself. Okay, you stay. This is a frequency analysis detection. What do? This is the title. You know what we have, or just pick anyone. Okay, let's say LED blinking control, a basic embedded output. So this is what you want. You copy, then you go to your AI, tell it, okay, generate. Okay, I think, don't worry, I think this one doesn't, I don't think it's necessary. This is, I'll be showing you some security if I'm doing that. So, I won't be, okay, let's just, these are some other practical you can do. You can do it fine. If you need any assistance in doing this, let me know, and then I will lend a hand. So, I hope you get it. So, just take care, and then bye for now.